Here's the agenda for tonight. We're going to start off with our featured speaker, Rod on En-ROADS. Then Graham will have a short talk on why solar and wind approach will fail us. Then we'll discuss plans for the coming year. First up tonight is our featured speaker. Rod will introduce us to En-ROADS, an incredible web-based climate model that helps us grasp the implications of climate change and how to address it. As you probably read, Rod has an engineering background. He taught at the University of Washington, managed technology at Cargill, and spent the last 11 years teaching high school science. He's now retired. He's in Eden Prairie. He is involved with Citizen Climate Lobby and volunteers as an En-ROADS ambassador. So I'm going to stop sharing and I'll turn it over to Rod to take it from here.
Excellent. And I'm going to grab a screen share right now. Well, first, thank you very much. And thanks, Tim Connors, for inviting me in. I've, of course, known about Climate Reality Project. And like I mentioned, I haven't been through the training, but I have friends that have. I've looked at your entire 500-page deck for some great information. So just to keep moving, and I'm sorry, this will seem like it's going to go really fast because what I'm trying to do, I typically would spend 45 minutes on. But first, let's just say and acknowledge that this year is going to be huge for climate. In spite of the chaos of the past week and the election, there is still a lot of cards stacked correctly for action on climate. And so I want to thank you all for the work you're doing, if at least for awareness in the community, but any other work too. I thank you for that. It's huge work. So what I'm going to do is give you an introduction to this model, and we'll quickly get into using the model. And I'm not, as I mentioned earlier, I'm not a training person for the model, but they have a tremendously good 8-part 1-hour video series on training. And so I went through the training. I'll get into that a little bit later. First, I should introduce myself. So, okay, who am I? Yeah, you just heard that, so we can skip that part. The one part I wanted to ask about you guys is who has seen En-ROADS demonstrated? Can you add up? I'm seeing, 3, 4, maybe. Okay, good. So that helps. And I know about your group, and whether you know about CCL or not, I guess that'll pan out at the end. So what is climate change and its effects? We don't have to talk about that because you guys are experts, so I'll skip that. And frankly, I found out as I've presented En-ROADS and climate action over the last 2 years to a whole bunch of groups, everyone from college classrooms to a couple staffers from the House or Senate, or a senator or a House member. So I've done lobbying with this. I've done community education with it, community groups, etc. And moving forward requires action, right? So I'm going to talk about that. How do we choose actions when the system's so complex? Well, that's why we have a model, because we can actually understand a little bit. So I'll talk about that. If we have time, I'll talk about carbon fee and dividend. Hopefully you guys know about that approach. And then the follow-up are these links that are in the chat. You can always email me anytime you want for any topic, but especially if you want to hear more about En-ROADS. Tim suggested maybe I would run a longer session. So if enough people come back and say, hey, I'd like to spend 45 minutes or an hour going through this and decide if it's something I want to learn about, I'll do that. Just let me know. And then the tools or the En-ROAD model is here. So this is what I'm going to show you. You can go click on yourself. And then this last link is the act bill before Congress for carbon fee and dividend, which my group, Citizens Climate Lobby, has been sponsoring. And we think it has a chance this year. So yay for that. Okay, you know about me, and I'm I'm a family guy, and I have kids, and I want to do stuff for the climate. I don't need to talk about these. These are actual slides. Most of this deck I gave to Ben Sasse. He's a senator from Nebraska, and I presented En-ROADS to him and his group. So I grabbed some Nebraska slides out of the great Climate Reality Project deck. But you've seen these, right? So trouble, trouble, trouble. And that was customized to them. So the real question is, we know that there's a problem with climate. How do we talk about possible solutions? So mitigation is the goal. And the standard expected rise, if we don't make big changes or significant changes in our carbon budget and the way we release greenhouse gases, the standard rise is expected to be 3.6 degrees C by the end of the century, 6.5 F. That's a problem. The long range goal, ideally, according to Paris agreement, was 1.5, but we've kind of blown by, or we're going to blow by that. So the goal is now 2 degrees C by 2100. And how do we do that? Well, we need near-term action, we need long-term action, we need to make decisions. And making decisions is the point of this presentation, really. So the thing to understand about the model, so I'm going to give you a little bit of an intro to the model. The model takes the mechanisms, the physics, the climate science, all of that stuff that has been able to be known and verified, and it puts it into a set of equations and allows you to run it. These are the models that are used, thousands of times a day, even impacting your life. Everything from weather to how does your smart car drive behind another car to, how does your doctor choose what medicine to give you after he runs a diagnosis. Models are everywhere, and they're usually so complex that only experts can run them. And that's the goal, or the glory of this model, is it's been simplified enough so people like you and I can run them. What do? They take all the inputs that would affect greenhouse gases, energy, land use, which is forestry, farming, burning forests, etc. Even CO2 removal, which includes agriculture, could include some technology. And other greenhouse gases. So it accounts for these, especially methane is the big one. It takes all of these, understands how they flow, puts them into a big balance and says, this is the greenhouse gas balance. Now, and then we know very, very well how that affects temperature, and that affects impacts right around the world, which you can easily name: floods, fires, hurricanes, droughts, etc. So this model that I'm talking about was put out by a group called Climate Interactive. It is a group out of MIT, the MIT School. Are we okay? Okay. So Climate Interactive out of MIT, their goal said, let's take this really complicated thing, and we have the models. There are dozens of these models, but really 6 to 8 that are the most relied on and agreed on worldwide. And it said, we're going to write a simplified version which still is accurate. And they did that. And here's some of the facts on it. I sometimes try to convince people that the model is great. I'll just run them by you and you can make your own decision. It's a global model, so it doesn't allow us to say what's going to happen in North America versus South America, what's going to happen in Nebraska versus Iowa. It says we're going to lump it all together, and look at the total global temperature, knowing that there will be regional differences. That's simplification number one. What it does is it says, how could changes in energy, economic, public policy affect greenhouse gas emissions and climate outcomes? It's built with knowledge of delay times, progress ratios, price sensitivities. If you read the literature, you're going to find all of these factors, which of course have been studied and verified, or at least tested in models. It's a high order nonlinear differential equation, if you remember your college math. And every time I move a slider, which we're going to do pretty soon, the application runs 14,000 equations with a time step of 45 days over 110 years. So it does all of that. So the model is running from 1990 as the kind of the start point up through today and on to 2100. All right. Here's a little bit more detail on the things going into the model. Not only economic policy choices, which, you know, do you want to put a price on carbon or subsidize or imagine some technical breakthrough? Here's the balance of the energy supply and the energy demand. We'll see that. Other greenhouse gases, and all that wraps up into impacts. So one more level of detail. So we're seeing, you see, we're going deeper. Simple, deeper, deepest. This is only one page of 100. Don't worry about any of the words on here. Just back up, cross your eyes, and realize that this is one page out of at least 100, because I went through the whole manual of all of the calculations and equations in the model. Every blue line on here is an equation, and that's how you get to 14,000. And so you're factoring in interactions and ways that systems build on each other. There's feedback, there's positive, negative feedback. All of that has to be built in these models, because not one thing can happen without it affecting 15 other things. And every one of those then has an impact. So all of that has to be recalculated every time we run the model. So think of 100 pages of this and you've got the model. And then we can, we won't talk about this. Oh, this was on here because I was talking to a Republican senator and I wanted to, you know, talk about some of the mitigations that he might be interested in, and therefore we talked about these ideas with the model, but we don't need to do that. So let's jump to the model. This is the model, but I have to jump screens so I can show you the live model. Looks like it's here. All right, so yell if you're not seeing the model and it's moving right now. Okay, and this is just it's a cheap little laptop running this thing. So I'm going to give you a little overview, and then you're going to help me solve the problem of climate change. The overview is, up here are the sources of energy. As you know, burning fossil carbon is the major source of carbon in the atmosphere. That's anthropogenic, that humans have added. So here's the energy story: coal, oil, natural gas, or fossil gas, renewables, bioenergy, which is ethanol and even burning wood, nuclear, that thin little blue line. These are all contributing energy. This is exajoules, but think of big chunks of energy. And remember, this is a global model. So we can look at this up through 2100 and see that coal is gonna keep increasing, even though in the US coal is dying out. You just heard one of the northern co-ops just yesterday announced their plan to shut down all coal. Xcel has announced their plan to shut down all coal. But worldwide, coal is still the cheapest in many countries, the cheapest and the native, meaning they've got it locally. So coal increasing, oil, this is business as usual, unless we make change. Then over here is, what are the greenhouse gases getting into the atmosphere? And again, this is amount versus time. And we've got CO2 and then some fluorine gases. We won't talk about them, but we will talk about methane. CO2 and methane, these are all on the basis, a similar basis of CO2, meaning, this isn't that much methane compared to CO2, but methane is much more powerful. So that's what it does. So there's greenhouse gas. This is the temperature we're trying to impact. And then down here are the things we can do. We can affect coal. How can we affect coal? Well, we could highly tax it, and that would, of course, bring down the use of coal. We can affect oil by taxing it. So just to give you an idea of things we can do, we can affect natural gas. All of these energy supply side, we can either incent it. So here's nuclear. We could incent nuclear, highly subsidize it, or we could disincent it, right? These are policy choices we can make. So that's the energy supply. In the middle, we have transportation. Do you want it to be more efficient, or do you want to electrify, like Mark Anderson's car? And I'm sure many of you, I know Tim Connors has an electric car. Or in building and industry, do you want to make it more efficient? Do you want to electrify it, get it off of natural gas, or in the case of transportation, fossil oil and gas? You can affect population growth. I'm not sure how, but you can. Economic growth too, which has some surprising results. Then finally, land and industry emissions affects methane, affects deforestation, and then carbon removal lumps into grow more trees, afforestation, or technological means of carbon removal. I hope you've heard of these. They're things, there's a whole list of things that can be done to remove carbon. I just went into greater detail, but here's a few down at the bottom: bioenergy, direct air capture, enhanced mineralization. Unfortunately, I don't have time to explain all of these, so hopefully you've heard of them, but that's the intro. Our mission now, it's participatory, is you tell me what to do to get this down to 2 degrees C by 2100 or sooner. Ready, set, go.
About everything we can, starting with producing new fossil fuel plants.
Okay, so tell me one thing. I will make it happen.
No more coal.
No more coal. So we're going to highly tax coal. And there's actually a way in there to just force it to shut down.
I would shut it down.
Do that. Yeah.
Let's see if we can do that. Reduction coal. Stop new coal infrastructure.
Yeah.
You get 5 years.
Yeah.
And that's it. Okay. This is worldwide coal over here now. You see? It takes a while for things to happen. That's the reality of, you can't just be king of the day and shut it off. It takes a while for things to get shut off. But there it is. Look at that. Worldwide, coal went down.
Hey, Rod, you might want to mention what you just did there. So you can use the slider bar.
Yeah.
To do kind of macro adjustments, but if you click on the little dots, you can actually drill down very specifically into the impacts on the coal and play.
They show you. What I'm showing you, folks, is the really top level in order to do it in 25 minutes, because what they do in training is show that we could show a whole bunch of graphs, which are great for analysis. We could show all the assumptions of the system, and a whole bunch more systematic analysis. And you're right. I think that was Mark who was saying that we can dive down.
A good place to start is probably playing primarily with the slider bars on the main.
Yeah, that's generally true, because that's what we have time for. And it makes the point, because the point I want to make now is we just knocked off coal, and it's pretty much zero by 2060, but it was really hacked down. And that's going to be a real trick worldwide.
And as you make those changes, keep an eye on what it does in the upper
Yes.
right to the temperature, because that's really.
Thank you. So now if I take it all the way back to where we were, and if you look at what happened, whoops, when I knocked coal out,
0.3 degrees Celsius. It's not near enough.
0.3 degrees Celsius, but also look what it did. The total energy usage didn't go down much at all, but it did have a very nice impact on CO2 because coal is, as you know, the worst emitter of CO2 for a given joule of energy. So great target. Next, we gotta go here. Oh, I'll give you
I
coal
played with
back.
it already, so I know carbon price is pretty influential.
Yeah, we'll come to that later.
All right.
So somebody else. Throw out,
Afforestation,
there you go.
planting trees.
Very good. I don't know if you guys remember 1 trillion trees. That was a policy that was being thrown around, I don't know, a year ago now. And I mentioned that because this, I was told, it's not explicit in the description, but I was told that this is, if I put this all the way to the right, it pretty much says, grow a tree everywhere you can grow a tree where there's not already people or farms. So there it is, high growth of a tree. So we went from 3.3 to 3.2.
God.
So that's a bit of a wake up call for people that were saying trillion trees, that'll do it. Well, it won't do it. It's nice.
No.
Nothing is bad. It's just not enough. Next, I heard somebody else.
Hey,
Yeah,
Rod,
subsidize renewables.
Which one?
Renewables, subsidize.
Enhance it?
Yeah.
Okay, we'll highly subsidize renewables. There's that green going. Now, what does highly subsidized mean? We could go in here and see, but it means, you know, you're 3 cents per kilowatt hour. And what these guys who wrote the model, they've, you know, obviously debated this with many, many policy people, and they want the sliders, the max and the min, to represent things that are within the realm of possibility. But even when they say highly subsidized, they say, wow, you're going to subsidize renewables 3 cents a kilowatt hour globally. You know, that's basically making it, because I think wholesale electricity today is, you know, a cent or less than a cent, sometimes down to a cent, tenth of a cent. So this is
my
a
God.
real big subsidy. But there it is. We did it. So what does it do? It gave us another tenth of a degree.
Well, new zero carbon.
Very good. This one is wacky. This one used to be called nuclear and other, but it's, so watch again, we're looking at new zero. So what does it include? I'll just jump here. It includes things like new tech, nuclear fission, not old tech, which, you know, is what we have today, uranium-based and plants, giant plants that nobody can afford, nuclear fusion, fission, et cetera. And we won't go into detail, but let's go ahead and make it happen. We got that big orange blip there. Now, notice two things. When does that kick in?
2040.
Not till 2040, because anything new tech takes time.
So that doesn't include renewables, huh?
No, this does not include renewables.
Interesting.
Yeah. So now we're down to 3. Next, somebody new.
Rob.
I have a question
Yeah.
on the model. Under that general category in the far right of carbon removal, you've got, we just played with afforestation. What about things like regenerative agriculture? Is that embedded in that as well?
Beautiful. No, you're right. That's down here. So, and that's a great one for the Midwest. I always bring this up when I'm talking about, here's agricultural soil sequestration, Charlie, you're talking about, and ways to do that. There's also mineralization, other ways, but this is the one in the Midwest that I'm pretty excited about. So let's use that. High growth. Now, what did we do here?
Oh,
That was
Over on the right, you notice now we've got this new gray bar, which is negative. because it's taking carbon out of the system. And we went, now this is a big ask, a heavy lift here, but we got 0.4 of a degree. Okay. Generally, when I do this, I say, well, you can ask for that, but you're probably going to get that. But just for reasons of explanation, let's go ahead and leave it there.
Let's try carbon price. Since
Yeah. Now, are you a ringer? Because this,
No, I do belong to CCL, but
there you go.
I'm curious.
Okay, I'm going to save that for the last one, Carol.
Okay.
Somebody
Okay,
knew.
so Rob, I'd
Yeah.
like to, let's presume that the population is an indicator to per capita consumption. And let's say that per capita, they've reduced consumption by at least half. So if you could
Right.
slide that slider down by half and see what
Well,
that contributes.
yeah,
to.
the real way to do that, Brick, is in economic growth. So,
Oh, okay, in the model, okay.
yeah, yeah. So this is low growth, which means low consumption, because people consume when they have economic wealth. And so this is worldwide low growth. And we could go into detail and see that. So what did we gain there on the,
With 2/10 of a point.
another 0.2? Now,
So for that economic growth one,
yeah,
we got about 3 billion people in the world right now that still use less electricity than a refrigerator does in a year. So are we assuming that they can continue to make growth, or do they kind of have to stay poor?
no, that's
in
the
the model,
exact,
'cause that-
Eric, you're exactly on the mark for that, because as economic growth is a worldwide thing and it will happen. And so this assumes economic growth worldwide, and it factors in the fact that there are emerging, developing economies, India, Brazil, et cetera, that are going to want to have more energy. So without low growth, it grows at this rate. If you say, nope, there's going to be disruptors of some kind, controls that control that, and then it's going to be here. So
Rod, just a heads up, we have about 5 to 8 minutes left. So
okay, thank you very much. So what I'm going to do now is jump to Carol's cool idea. We didn't get there, but what we can do is I'm going to go back to square one and say, what if we put a price on carbon? And the price, and this is where CCL has been working for 10 years, actually negotiating with everybody under the sun, including many on the right side of the aisle. And I'm going to assume that we can start a bill in 2025. It happens the first year that we put $15 a ton on a price on a ton of carbon emitted, and that would add about 15 cents to a gallon of gas. Then we're going to say we're going to add 10 more dollars per ton per year, so it's slowly increasing, and that's going to start in 2026 when that happens, and that'll take 75 years, obviously. So here's the ramped up cost of carbon, which is steady and predictable by all the financial institutions, by the companies, so they know what's coming. And I just want you to see what that did. We turned that on. So we're comparing this to this.
Mm-hmm.
And what that shows, and if we spent an hour on this, it did pretty much more than everything else we had done. It didn't get us there. And we'd also still have to do an attractive job on methane, maybe a little bit of CO2 removal. And suddenly, we're within the, oh, here's the other thing, and Mark was alluding to this. Look at this. We've generated this much energy, and obviously if this is renewables, it's all electric, right?
Mm-hmm.
And so I don't know if the follow-on presentation is going to be about this, but if we don't use that electricity, we're sunk. And you can't just use it for light bulbs. You've got to use it for transportation and buildings. So we need to electrify the systems that we have. And then you can definitely get to 2 and even beyond it by a few more. And here, we haven't even done any new carbon. Now, that's the kind of the good news of carbon pricing. We think it is market-based, and that's what the group I'm in, CCL, is really promoting. So this is just a touch of the model. And what I do typically, what I found, because I was presenting kind of a CCL story before this model came out. It's only been out a year. And I would present, and people would politely thank me. But as soon as I started presenting with the model, I just had a whole bunch more engagement from people that could see, and normally I'd have a little more time, and they could see what their things would do. They could see it was complicated, but they could also see potential for progress. And that's really where I'm trying to, say it again and again and again. This is an upside. It's a win-win-win, because what we just designed there is a lot more jobs. It's a new economy beyond the old economy we've had for 150 years. And it can actually do work on the climate. So I won't go into the rest of my slides, but they're basically a little intro to CCL, but you've seen it. But that's the overview of a model. There are others, but there's no other model that I know of. There's one other that you can run at home, but this one is really just done a great job of making it approachable. Okay, Tim, I'll stop there with stuff and I can take questions, or you cut me off if you need to.
Okay, why don't you exit the screen, and maybe we could have time for up to 3 questions. Anyone wants to go?
I have one. I didn't hear anything about energy storage. Is that factored in somehow? What kind of assumptions did they make about?
Yeah, very good. I've been looking at that a lot. You're talking about for the grid, I assume. So
I guess.
Yeah. Energy storage, electrical energy stored needs to be figured out so that the grid can be robust beyond sunny days and windy days. The model, as I know, doesn't assume any major breakthroughs. That would have to come in that breakthrough slider. They've been talking about this, but they just don't have enough to go on right now to, beyond people's hopeful thoughts on what energy will be coming. Will it be lithium? Will it be flow batteries? Will it be hydrogen? There's just all these things out there, but nothing has emerged. Yeah, good question.
Say, Rod, have you ever taken this back to high school students and see what they think?
I did Minnetonka School. I talked to their climate group one day, and I love talking to the more, I would say, more progressive, we got to get out there and do stuff because I love their energy, but also because they kind of go, wait, it takes 20 years for something to happen, if you're talking about new technology. It's kind of a shock to their system to realize how much momentum and time lag is in this, and it's depressing too for them because they don't feel like.
We have time for one more question. Anyone?
I can ask one if nobody else has one. I'm curious, Rod, have you looked at Biden's plan or any of the Democratic plans and kind of married that up to the different categories that are in your?
Well, that's a great point, Mark. We have analyzed Biden and the Dem platform and a couple other committees that have come out because that's what we had to look at. I haven't seen them run on the model. They don't line up very well with anything, and of course there are a lot of aspirational things. So the short answer is no. Well, yes, we have looked at them. No, I don't know what their impact will be.
Yeah, not
for the model.
big enough yet, maybe.
Yeah, that's a good point, though.
Maybe we'd have a round of virtual applause for Ron. Very good.
Please, if you want to talk more about it, I'm here. This is what I do. So email me, and we can do more, but I highly encourage you to at least look at the training and the links in the chat, because the training, you can learn a lot. And even if you don't want to be a person that demonstrates it, you can learn a lot and have fun.
I just
Okay,
wanted-
thank you. Thank you,
one comment
Tim,
I wanna
and
make, you know,
group.
in looking at the Climate Interactive website, and just for the benefit, and many of you on the call may know this, but Rod can run a much more in-depth workshop, and we can have a much more highly interactive group about what if scenarios and maybe some assignments ahead of time, so that we come a little bit more prepared, because I do think it helps everybody think about, you know, the various actions and activist activities that they're involved with. And like you say, Rod, you know, the unfortunate hard dose of reality is we think when we make a decision, we advocate for something that's going to have an immediate impact, but it can take a while, right? So it's picking and choosing the battles, right?
But the upside, I didn't show the economic growth in all of those scenarios, but it is really positive, and it's a net positive.